Hey everyone. So I believe this is example number 8 from last Wednesday's notes. And the goal here is to state the value of theta. Last Wednesday's notes. Let me give you a diagram. So let's draw something like this. Let's draw the ground. And then let's draw a little human being. Okay. And then off at a distance, let's try to draw le Tour d'Eiffel, the Eiffel Tower. So, wow, how do you, something like this, watch. Go something like that. And then maybe like this. Okay, so don't laugh at me, okay? Something like that, okay? Something like that. Little antenna. So let's just pretend that this is the Eiffel Tower. And as it turns out, it's 1 mile away from you. And the tower, let's say from top to bottom, I believe it's 984 feet. Now, your eyes usually go like this. That's your normal line of sight. But you want to look at the very top of the tower. So really, your eyeballs are looking up there, okay? And this here, this is called the angle of elevation because your eyes are elevating up toward the sky. Let's call that theta. And as it turns out, your eyes are not on the ground. They're a certain distance above the ground. Let's say that distance is 5 feet. So this is the setup. Now let's find the value of theta. What I want you to see, guys, is that there is a red triangle sort of here. You see this red triangle? So what I want to do is I want to draw that red triangle down here without all of the other distractions. So wouldn't it look something like this? It's not drawn to scale, right? This would be theta. And now 1 mile would be here, but you know what I'm gonna do? I'm gonna turn it into feet because everything else is in feet anyways. Now, I know that this says 984, but that's not what this is. This would be 979. How did I get that? Well, because you have to take away your 5-foot eye height from the height of the tower. That's how I got this here. Put a little 90-degree symbol there. How can I find theta? Well, why don't we quickly label hypotenuse, adjacent, and opposite? For sure, that's the hypotenuse. From your position, across from you is opposite, making this the adjacent. So, am I going to use sine, cosine, or tangent? Recall the models from last week. We have an opposite and an adjacent. So that narrows it down to either tangent or cotangent. But for now, we're only playing with this first column. So we're going to use tangent. So let's set up our tangent model. So we have the following. We have tangent. Tangent equals opposite over adjacent. Now let's fill in the information that we have. Do we have theta? Well, just call it theta because we don't know what the angle is. That's the goal. But we have the opposite and we have the adjacent. So we have tangent of theta equals 979 over 5280. And then recall from last week how that anytime you want to find an angle, you're going to need an inverse. So let's take the tangent inverse of both sides. So take tangent inverse of the left and take tangent inverse of the right because we know what happens. We know that this knocks this out so that it's just theta here. And then we can go Casio and we can type in tangent inverse. Make sure you're in degrees. Tangent inverse of that And to the nearest tenth, folks, to the nearest tenth, it should be about 10.5. So about 10.5 degrees, right? Degrees. So before I let you go, does this number even make sense? You know, the Eiffel Tower is really tall. I would think that I'd have to go like this because it's really tall. But where are you? Are you standing directly next to the tower? Because if you were, you'd be like this. But now look, we're 1 mile away. We're so far away from the tower, so that since it's so far, I don't have to go like this. I really just have to go like that. See what I'm saying? That's why it's only 10 degrees of elevation. So this answer, it makes sense. So now go and try exit ticket number 8. There's only one problem, and it kind of sort of has this flavor to it. So give that a go, and I'll talk to you guys tomorrow.